exercise 1.1. In that we are going to see the third sum. Let us see now. If f alpha is equal to this, they have given, and they have asked us to show that f alpha inverse is equal to f of minus alpha. Here this f alpha inverse is nothing but like A inverse. If a determinant mentioned by A, we say A inverse, like that f alpha inverse. So now let's go on to see how it should be solved. First we have, for finding out inverse, we have to see the determinant value of f alpha to see whether it is singular or non-singular. If the determinant value is 0, it is singular, f inverse does not exist. If it is not equal to 0, it is non-singular, f alpha, that is inverse, exists. So now we will expand, we will see the value of the determinant value for cos alpha. That is, expand this in the determinant method. Determinant we use just 2 bars. Here we expand through the first row, that is row 1. Expanding through row 1. So what is that row 1? Cos alpha into, close that row 1 column, the remaining numbers you put 1. Next, minus 0, that is the first row, middle element. So close that row and that column. So the remaining elements, the last element, sin alpha. So let us see the value, how it goes on. Cos alpha. Now you have to just see the value of the above 2 into 2 determinant, like cos alpha minus 0. This term becomes 0 into anything is 0. So the last term, sin alpha. So that is 0 minus of minus sin alpha, that is plus sin alpha. Now this becomes cos square alpha, and this cos into 0, 0 and minus 0, and here also sin into 0, 0. So sin alpha into sin alpha, that is sin square alpha. So what is cos square plus sin square? We know in the 10th, 9th, from the 9th standard we are learning trigonometry. Cos square alpha plus sin square alpha is 1, and that is not equal to 0. That is f alpha, the value of f alpha, that is determinant value of f alpha is equal to 1, it is not equal to 0. Since f alpha, that is the determinant, is a non-singular matrix, f alpha inverse exists. This line is important. It should be mentioned. There are marks for such lines, such confirmations. It is a singular or non-singular matrix. So now we can continue the sum because F alpha inverse exists. Now we'll find adjoint of F alpha to find the inverse. You know the formulas for inverse. So now the next duty we have to find. We know the 1 by F alpha determinant value. Now we have to find adjoint of F alpha. Transpose of the cofactor matrix. So let us see that now. 1, 0, 0 cos alpha. The transpose of this matrix. So transpose of this. Now let us simplify that. That becomes cos alpha Now what is transpose? The first row is taken as first column, second row is second column, third row is third column. So this is adjoint of F alpha. Therefore, F alpha inverse is equal to, so let us substitute here. Now determinant value was 1. So it is 1 by 1. If you mention the formulas, definitely you will get marks for the formulas in that correct places wherever you require. Now adjoint. We have found out the adjoint. We'll write here. F alpha inverse. In the sum we have, they have asked us to prove something like F alpha inverse is equal to F of minus alpha. Now we have to see what is F of minus alpha. That is, you know what is F of alpha in the beginning they have given. Now what is F of minus alpha? That is, we have to put in minus in the angular places, like cos of minus alpha 0, sin of minus alpha. All the alpha should be replaced by minus alpha. Here you should know this. Cos of minus alpha is cos alpha and sin of minus alpha is equal to minus sin alpha. Cos of minus alpha is equal to cos alpha is called even function. Sin of minus alpha is equal to minus sin alpha is called, sin alpha is an odd function. So this becomes now, what is F of minus alpha now? Cos of minus alpha, you write cos alpha 0. But sin of minus alpha, you should write it as minus sin alpha. Again here it is, already minus is there, so minus of minus plus it will become. So now we have to remember inverse answer, take it as 1. So from 1 and 2 we have proved inverse is equal to f of minus alpha. Thus prove.